An electrode has a wire core that is usually coated with a baked flux. This flux contains several materials which help the flux serve many purposes. We can see how by going over what happens during stick welding. During welding, current flows through the electrode. An arc forms between the end of the electrode and the metal pieces that are being welded. The extremely high temperature of the arc melts the wire core and the flux coating at the tip of the electrode. It also melts the metal that is being welded. The metal pieces melt together to form the weld, while the melted wire core adds metal to the weld. When the flux coating melts, some of its materials turn into the gas that shields the molten metal by displacing the oxygen, hydrogen, and nitrogen in the atmosphere near the weld. The gas shield also helps to stabilize the arc and to reduce spatter. Other materials in the flux coating help remove undesirable elements from the weld pool. Also, any alloy elements in the flux coating are added to the weld pool to change the chemistry of the metal in the weld. Adding alloy elements can serve many different purposes. For example, alloy elements can make a weld stronger. The remaining materials in the flux coating melt to form slag, which is a cinder-like waste product. The slag forms a coating over the weld, allowing the weld to cool slowly and forming a barrier between the cooling weld and the atmosphere. If any weld is allowed to cool too quickly, or if air is permitted to combine with the molten metal, the end result will be a weak, brittle bond. Coated electrodes for stick welding are available in several varieties, each with a specific application. Differences among the varieties include size, type of coating, and type of wire core. Because the electrodes that are used for stick welding become a part of the weld, care must be taken to select the proper electrode for the job. The correct selection of electrodes can be made only if the welder understands the identifying code system that is used to classify the various types of welding electrodes. Code numbers are generally printed directly on the electrode, although very thin electrodes may be color-coded instead of labeled. Welding electrodes should be carefully stored prior to their use. The amount of moisture present in the coating is very important, and too much moisture will cause many types of welding electrodes to perform poorly. Welding electrodes will absorb moisture from the air, so the shipping packages should not be opened until the electrodes are needed for immediate use. To keep moisture out, the shipping packages are usually metal cans or plastic-wrapped containers. Electrodes that have been taken out of their package can be stored in a heated oven. Manufacturers recommend temperatures for each type of electrode. However, a temperature of about 120 degrees Fahrenheit, which is about 50 degrees Celsius, should be suitable for most types of electrodes. If electrodes do pick up excessive moisture, they can be baked in an oven, but the manufacturer's instructions must be followed for the correct time and temperature. In this part, we looked at the equipment that is used to perform shielded metal arc welding. We saw that a wide variety of short, consumable electrodes are used with this method, and that they must be handled and stored carefully. Now would be a good time to try a question on shielded metal arc welding. In this part, we're going to go over a common method of arc welding that's called gas tungsten arc welding. You may also hear this method referred to as tungsten inert gas welding. That's why you'll hear this method called TIG welding, especially around the shop. Sometimes this method is referred to as heliarc. That's because helium used to be extensively used as the shield gas. TIG welding was developed in the early 1940s as a way to weld aluminum, magnesium, and nickel, which were being used to make military aircraft during World War II. TIG welding was first done with motor generator machines. In the 1950s, rectifiers that could provide the current required for TIG welding were developed. This allowed transformers to be used as a power source. Later, high-frequency units and remote control units expanded the breadth of TIG applications.